This is AP Calculus AB Worksheet 3-4 Graphical Analysis for F concave up, F concave down, and F inflection point. So we have now 9 things in our speed sheet definitions that we should be ready to use at all times. Let's go ahead and read our directions. We're supposed to label critical values, F relative extremum, F relative minimum, F relative maximum, F inflection points, and then we're going to go ahead and do all of this stuff as well. So first of all, you have to pay attention to what sort of graph do we have. Notice that there's a difference between a graph of just the normal function like g, and there's a graph of h prime, which means it's the derivative. These are very, very different graphs. And I don't know, in the back, do we ever get a double prime? We only limit it to single primes on this one. So let's go ahead and see. So first, I'm going to remind myself the definition of a critical value. A critical value is where f prime is equal to 0 or f prime does not exist. On a graph of g, what is g prime? G prime is slope. So here I'm really doing the definition of g increasing is the same thing as g prime is greater than 0. On this graph of g, g prime is slope. So I'm really translating this thing and saying that this is where slope is greater than 0. Same thing down here, g decreasing means g prime is less than 0, therefore the slope has to be less than 0. What about g concave up? G concave up, the definition is up above, but it's where g double prime is greater than 0. G double prime on a graph of g is the concavity, so it's where it's concave. Let's just say concavity. Concavity is greater than 0. Same thing down here, g concave down is g double prime is greater than 0, and I translate that on a graph of g, g double prime is concave, concavity is greater than 0. All right, so I have my definitions ready to go. This is going to help out a lot because a critical value is based on slope because that's g prime. I'm looking for where I have a g prime that is equal to 0. I'm looking for a slope is equal to 0. So I can see over here, if a slope is equal to 0 at this point right here, which looks to be at x equals -1, I'm going to label that as not an FCV, but a GCV. And down here as well, this spot right here is going to be a GCV, a critical value of our G function. What else do we have? And you might say that the slope at this point doesn't exist. I'm going to go ahead and ignore that for a bit. It's just an endpoint. It's not super valuable to us. What else do we need? We need relative extremum. So where do I have a change between increasing and decreasing? That's kind of the definition of a relative extremum, a secondary definition. I notice that, let me fill this one out. I think it's going to help me first. A G is increasing wherever I have a slope that is greater than 0. Slope is greater than 0. Let's go ahead and highlight that in green. The slope is greater than 0. This positive slope, I want to do a highlighter here. This positive slope right here, and this positive slope right here. So slope is greater than 0, and I'll write this down in my notes. This is where I'm between negative, it doesn't start at -2 though, but I have to be careful because this is an arrow. It goes on forever and ever and ever, technically to the left as well as down, which means I can't just say -2. It goes from negative infinity all the way to that -1. So this entire interval has now been captured in our not inequality, but our interval notation. And then this needs to be captured as well between 1 and 2. It does hardcore end at 2, so I can say, and 1 to 2, 1 to 2. G decreasing, again, that's going to be the other direction where I have slopes that are negative. I didn't want to do a straight line there. This is going to be, G decreasing is going to be between -1 and +1. And what about G concave up? We'll label the graph in a little bit. G is concave up, or my concave, I'm being concave up, I guess. So I can say up here, I'm concave up here, and I'm concave down here. It's really hard to figure out where it changes concavities. It's clearly concave down still there, concave up right there. I think it changes right in between. I'm going to say that zeros are inflection points. So it's concave up everywhere between 0 and 2. So we'll say between 0 and 2. That's talking about this entire interval right here is concave up. And then everything over here, and it goes all the way to negative infinity, is going to be concave down. So from negative infinity all the way to the inflection point of 0. We'll say from negative infinity to 0. is going to be concave down. And then we need to label some things. I talked about it before, but this point right here is going to be our G inflection points, our GIP. Do we have any relative minimums or maximums? Well, I know that I have a maximum. I mean, it's the top of the graph. It's the graph of G. So this is a maximum. Another way to tell that is I had something that was increasing, something that had a positive slope to something that had a negative slope. Whenever you change from a positive slope to a negative slope, or a positive G prime to a negative G prime, that is a definition of a relative extremum, and it's technically a definition of a maximum. So I'll say both of them. This is a G relative maximum, and it's not only, this is like the general umbrella of what you can be. What type of relative extremum is what I meant to write here. G relative extremum, and it's also a relative max. So this is a G relative max. An extremum is just a umbrella word for both maximum and minimum. So then you have to ask the question, which one is it? It's a maximum. And then down here we have another relative extremum. So I'll say this is a G relative extremum. What type of extremum? Is it a minimum or is it a maximum? Well, it's a G relative minimum. The definition of a minimum is where I have something where G prime is negative. G prime is a slope. So the slope is negative and the slope is positive. That changes right here. All right, did I get everything? Let's go ahead and read the instructions. We got our critical value, yep. Relative extremum, yep. Minimum, maximum, yep. And our inflection point, got it there. We got all the pieces. Let's go on to number 2. So on number 2, I have to be really careful. Again, it's the same definitions as before, but it's a different interpretation. H increasing is H prime is greater than 0, but H prime on a graph of H prime is now height. So we need height to be greater than 0. And same thing, H decreasing is where H prime is less than 0. Therefore, it's where the height is less than 0. H concave up is where H double prime is greater than 0. So now you ask the question, what is H double prime on a graph of H prime? Well, that's slope. So it's where slope is greater than 0. And then H concave down is where H double prime is less than 0. Therefore, it's where the slope is less than 0. Let's go ahead and do our analysis over here. Where is the height greater than 0? Well, the height is greater than 0 on this interval. Let me do it in green. This interval right here, the height is above the x-axis. So we'll say this is between -2 and +2. And where is the height negative? The height is negative when I'm beneath the x-axis. That height is negative down here, and it goes forever and ever. We'll do like a little arrow that direction. This goes down forever and ever. We'll do an arrow in that direction. And we can say that is from -infinity all the way to the x-coordinate of -2, as well as from 2 all the way to +infinity. And I know that I've said this in the past, but whenever I have 2 intervals, technically the way that you're supposed to do that is with a union. You do like a little U. Saying and is not that far off. Usually you can just do like a comma in between and call it good. I'm doing and, which is mathematically incorrect, but it makes sense to most students, so that's what I'm going to stick with. Where is H concave up? Where's the slope greater than 0? Well, I have a positive slope, positive slope, positive slope, positive slope, 0 slope, and then a negative slope, a negative slope, a negative slope. So I have these positive slopes over on this area, and that's where I'm going to have my concavity. So this is going to be, I'll say, that's from -infinity, and that concavity switches when I hit 0. And I'm concave down from that 0 all the way to +infinity. So let's go ahead and label what we've got. So in terms of looking for relative extremum, I think that's one of the first things. It's a critical value first, and then we can determine if it's a relative extremum or not. I need to find where, let's see, I'm looking for an H prime is equal to 0. H prime is a height equal to 0. I have a height equal to 0 here and here. That's the definition of an x-intercept. So I can label these things as an H critical value. This is an H critical value. This one right here is also an H critical value, H hyphen critical value. Okay, if it's a critical value, then it has a potential of being a relative extremum. To be a relative extremum, you have to have a sign change. Well, did it change signs? It was a negative height, and then it was a positive height. So that is a change of signs. This one was a positive height, and then a negative height. That is a change of sign. So it is an H relative extremum in this case. This is an H relative extremum. And then since it is a relative extremum, you have to ask, well, what type of extremum? Is it a minimum or a maximum? I had a negative to a positive. That is the definition of a minimum. So this is an H relative minimum. And then this is an H relative. Well, let's see. I had a positive height up here, and then I went to a negative height down here. A positive to a negative is a definition of a maximum. This is an h relative maximum. And the only thing that I'm missing is my inflection point. Where do I change concavities? And you can see, well, I was concave up, and then I was concave down. That changed when I hit 0. This is the boundary line. I had positive slopes, and then I had negative slopes. So that means I have an inflection point here. We'll say that this point right here is an H inflection point. And I think I have all the vocab terms here. Let's just go ahead and double check. Yes, got all of them. All right, perfect. Moving on to number 3. Now we're talking about a graph of J. So we have a graph of J prime. We have to be careful here. Let's start with a speed sheet definition of what it means to be J increasing. J is increasing where J prime is greater than 0. On a graph of J prime, what is J prime? Is it height, slope, or concavity? Well, it's height. Therefore, height needs to be greater than 0. J decreasing is where J prime is less than 0. So that's where I'm looking for a height that is less than 0. What about J concave up? That's where J double prime is greater than 0. What is J double prime on a graph of J prime? Well, that's slope. So I'm looking for where slope is greater than 0. Same thing for J concave down. That's where J prime prime is less than 0. Therefore, it's where the slope is less than 0. All right, so let's find our J increasing. Where is my height positive? Where am I above the x-axis? Well, I'm above the x-axis there and there. Let's go ahead and highlight those really quick. We can say I'm increasing here, and I'm increasing there. So this is going to be where I am between -2 and 4, as well as from 6, I'll say and, even though it's not technically correct, and from 6 to 7. There is no arrow going off in this direction. It's just a point, so I know it ends. Just a point, I know it ends. It's decreasing where it's below the x-axis, where the height is negative. So I can say it's negative. Let's go ahead and highlight. It's negative on this interval because I'm beneath the x-axis. It's negative on this interval because beneath the x-axis. That happens from 0 to 2 for those x-coordinates, as well as between 4 and 6. Okay, where am I concave up? Well, concave up is asking where's the slope positive? And the slope is positive. Let's see, I have a slope that's negative. Oh, the slope is positive. The slope is positive, 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 and then all of a sudden 0. So in this interval right here, that's where I'm concave up. I'm also concave up where I'm positive over here as well. So I'll mark both of those points over here, and I'll say it's concave up between 1 and 3, as well as the other positive slopes between 5 and 7. Where am I concave down? I'm concave down when I have negative slope, so I'm concave down here, and I'm concave down here, and I'm still concave down here. Am I concave down at 4? It's kind of a fun question to ask, and the answer is I don't know, because the whole point is we're talking about slopes. What is a slope at 4? Well, is it that slope or is it that slope? They're very similar, but they're different. This is what's known as a sharp corner. I don't know. You can't include that point. So I know that J is concave down between 0 to 1 because I have negative slope, and I know between 3 to 5, so I'll say and 3 to 5, but the problem is I don't know about 4, so I have to go from 3 to 4, exclude 4, and also go from 4 to 5. Normally I would go from 4 to 5, but again, I don't know. This is I'll label it in the notes. This is a sharp corner. Sharp corner. Sharp corner means don't know the slope. Excellent. Let's move on to question number 4. Wait, did I get them all? I did not get them all. Oh, I'm going too fast. First, let's label all the critical values. The critical values are where J prime is equal to 0 or does not exist. So I have a lot of them on this one. I have a J critical value at 0, a J critical value at 2, a J, that has a capital J, a J critical value at 4, a J critical value at 5. Why, Mr. Snell? That's not a 0. That was a 0, that was a 0, that was a 0, and that was a 0. Why did you say that's a critical value? Well, let me ask you a question. What is a slope at that point? Is it a slope that is positive 1 or is it a slope that's negative 1? And the answer is you don't know because, yet again, it's a sharp corner, so it needs to be a critical value because a slope does not exist. Again, slope is, by definition, I don't know about slope. I have to be careful there. for the j double prime, that one didn't exist. I don't know if this is a critical value. I don't think that it is. I apologize. I am incorrect here. Here, let me talk about why I'm incorrect, because it's a really important question to ask. You say sharp corners, the slope doesn't exist. And I agree, the slope doesn't exist, but the slope is talking about j prime prime, the second prime. But in this case, I'm only asking you, where is a single prime? Where does the height not exist? In order for the height to not exist, you'd have to do something crazy, like you'd have some graph like this, and then it jumps down like that. There is no height that exists in some graph like that, but the height does exist. The height is, I don't know, maybe it's -1 or something. The height does exist, therefore it still does exist. So it's not a critical value. There's only a critical value over here at 6. That's a j critical value over here at 6. Okay, now that it is a critical value, you have to assess, okay, well, is it a relative extremum? And in all of these cases, it kind of is, except for this first one. A relative extremum means it has both a positive and a negative value in either order. So over here, this had a negative value and it went to a positive value. Notice how it switched signs. If there's a sign change, that is a relative extremum. So this one is a j relative extremum. Why is this one not a relative extremum? Well, it has a height of negative, but I don't know what happens over on the left side, so I can't verify if it's a relative extremum or not. Over here, I went from a positive height to a negative height, so this this critical value is a relative extremum. I can say it's j relative extremum. And then over here, the critical value, you have to assess, okay, is that a relative extremum? Yes, because it went from a negative to a positive. It had a sign change, so you can say this is a j relative extremum. And then finally, we have to say, okay, now that we know that it is a relative extremum, which type of relative extremum? Is it a maximum or is it a minimum? And you have to use that definition. A minimum goes from a negative to a positive, so this is a minimum. I'm going to say j relative minimum. Down here, I went from a positive to a negative. If you start with a positive, the answer is a maximum. This is a j relative maximum. And then over here, I went from a negative to a positive, which means this critical value, this relative extremum, the type of relative extremum is a j relative minimum, because I started out with a negative. Cool, I got all of them labeled. Do I have any inflection points? And the answer is yes. Did I get the inflection point in the last one? I did, okay. The inflection point is where you change between concavities, between concave up and concave down. You can see, I was between 0 and 1, I was concave down, and then I switched from 1 to 3. So this border of 1, this is where I switch signs. And you can use the speed sheet definition, which is even easier. Okay, you say, okay, an inflection point is where you have a j double prime sign change. J double prime is slope, so you're really saying, where do I have a slope sign change? I have a slope of negative and then a slope of positive. That's a sign change right here. This is a j inflection point. Where do I have a slope sign change? Well, it's still positive, 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 negative. I change signs right here. This is a j inflection point. Okay, let's test. I'm negative, I'm negative, I'm negative. Do I change signs here? It's a negative and still a negative. Even though it's a sharp corner, it's not an inflection point because you did not change signs. It's still a negative. Negative slope and then positive slope. Okay, I switch signs right here to a positive slope, which means this point right here is a j inflection point. And then I'm positive, 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 positive slopes, and there's all of our inflection points. All right, front side is done. Let's do the back side. Number 4. All right, so let's talk about m. Am I increasing or decreasing? Well, m increasing means that m prime has to be greater than 0. What is m prime on a graph of m prime? Is it height, slope, or concavity? If you said height, good job, you got it right. This is translated to height, now is greater than 0. Therefore, these, I'm going to translate them a little bit faster. I'm just going to say that these are heights that are less than 0. Concavity, I need to go back to that speed sheet definition. Concavity means it's m double prime has to be greater than 0. Translate, what is m double prime on a graph of m prime? Well, that's slope. This is slope has to be greater than 0. And therefore, this one has to be slope is less than 0. Let's go ahead and do the more analysis. We'll say, okay, let's go ahead and find the increasing intervals. Increasing means height is greater than 0. Anything that is above the x-axis is increasing. So you're increasing right here. We'll say that's m increasing. This is m increasing as well. And we can say those intervals were between 0 to 2, as well as from 4 to 5. Where am I decreasing? I'm decreasing when I'm below the x-axis, when my height is negative. So down here, I'm decreasing, and right here, I'm decreasing. Those intervals are between -1 to 0, as well as from 2 to 4. All right, let's talk about the concavity. Where do I have a slope that is positive? Positive slope, positive slope, positive slope, positive slope, positive slope, still positive slope, still positive slope, still positive slope, still positive slope. Everything is positive slope. What is the slope at 2? I don't know. It's not continuous. I don't have a slope at 2, so I can't talk about slope at 2, so I have to exclude that. And I can say my final answer for concave up, it's between -1. I have to cut it off at 2 because I don't know what happens at 2. I'll say, and then start at 2 again without including it, and 2 all the way to 5. All that is concave up. Where am I concave down? Nowhere. Nowhere. All right, let's go ahead and label the graph with everything that we need. Let's first do a critical value. That's usually the first step. Critical value is where you have a height in this case, because height is m prime. Whereas m prime is equal to 0 and m prime does not exist. Whereas a height equal to 0 or a height not exist. The height does not exist at 2, maybe? It's unclear. This graph could have been better. It would be really nice to see if that was a solid point. Maybe that was an open point. Or something like that. Or maybe they're both open points. If they're both open points, then the height does not exist. It's unclear what's going on here. So you can make an assumption here. My assumption is that it exists at least one of those points. Maybe it's there, maybe it's there. So I'm going to leave it there. I'm going to say the height does exist somewhere. Let's pretend maybe it's down there or something. Where is the height equal to 0? Well, there and there. Let's label those as m critical values. This is an m CV. This is an MCV. So we got these 2 points are MCVs. I can't say that this is a critical value because I don't know what's going on there. There's an argument to be made for either side, so I'm going to ignore the argument and just ignore it. All right, so now that's a critical value, you ask, is it a relative extremum? Did I actually change signs? I had a negative height, and then I had a positive height. That is a change of signs. Therefore, it is a relative extremum. This is an M relative extremum. And this one is also an M relative extremum. Why? Because it changed signs. And now that we know that it's a relative extremum, what type is it? Is it a minimum or a maximum? This one went from a negative to a positive. This one also went from a negative to a positive. You always read from the left to the right. So it's negative first, negative first. If it's a negative first, that is a minimum. So it's an M relative minimum. This one is an M relative minimum. And do we ever change concavities? Not necessarily. We're always concave up. The one exception is an inflection point is a change of M double prime. It's an M double prime sign change. Did M double prime ever switch to a positive to a negative? Well, no, because M double prime never was concave down. So I can't have any inflection points on here. And I'm done with my labels up here. All right, in number 5, what do we have here? N increasing, so just give the species definition again. This is where n prime is greater than 0. And on a graph of n prime, what is n prime? Well, that's height. So you'll translate this and say this is where the height is greater than 0. So this is where height is less than 0 for n decreasing. And then do the species definition of n concave up. Well, that's where n double prime is less than 0. What is n double prime on a graph of n prime? That is that is slope. So its slope is less than 0, and therefore n concave down is where slope is greater than 0. And let's do that analysis. Let's apply it. Okay, where do I have a height that is greater than 0? I have a height greater than 0 everywhere with an exception. This height is exactly equal to 0. This height is exactly equal to 0. So it's not increasing at these 2 specific points, but it's increasing everywhere else. So I'll go ahead and highlight that in green and say, okay, it's increasing there. It's increasing on this entire interval, and it's increasing there, but it's not increasing there or there. So I have to exclude that from my increasing interval. I can say everything between -1 all the way to 0, exclude the 0, and then start up again, excluding the 0. It's from 0 to 4, exclude the 4, and go from 4 to 5. That's where I'm increasing. Where am I decreasing? Where's my height less than 0? Well, there's no height less than 0, so nowhere. Say nowhere. Okay, then concave up. So where's my slope less than 0? Well, that means I'm going down. This is slope less than 0, and this is slope less than 0. Those 2 spots right there, I'm going to write up and say between -1 to 0, I want to do this in a different color though. I'd rather choose red. This is from -1 to 0. I have a decreasing slope, and as well as between 2 and 4. Again, you can see there and there I am decreasing. I have a negative slope, and negative slope in this case means concave down or concave up. Sorry. Why am I messing up so hard? Concave up is where I'm positive. Why did I say it's less than 0? If you caught that, please log it. I should be saying the opposite. Don't know why I'm saying wrong things right now. This is where concave up is where I'm greater than 0. Greater than 0, slope is less than 0 for concave down. Thank you. Okay, now I have it correct. So where am I concave down? Where's my slope less than 0? That is where I was less than 0, so let's go ahead and move you down there. Now I'm correct. Where am I greater than 0? I'm greater than 0 where I have positive slope. Positive slope is there. Positive slope is there. So that's between 0 and 2 and 4 and 5. So between 0 to 2 as well as between 4 and 5. And then we need to label the graph on everything that we can see. Again, I have some weird things happening over here in terms of a slope. What is the slope at those points? We can't have a slope at a point if you don't see the rest of the graph. So it's not clear, but I can tell you this. I have critical values wherever I have an n prime equals 0 or a height equals 0. Height is equal to 0 here and here. Therefore, those are my critical values. I can say this is an n critical value. This is an n critical value. If it is a critical value, you can go a step further. Is it a relative extremum? Did it have a sign change? Well, the height here was a positive and it was a positive, which means there was no sign change. It is not a relative extremum. There is no minimum, there is no maximum. What about over here? Positive to a positive height, there is no relative extremum. Done. Anytime that you switch between concave up and concave down, you should have an inflection point, and indeed you do a few times. So notice over here, I'm looking for a slope sign change because I'm looking for an n double prime sign change. So slope sign change, well, negative to a positive, there's a slope sign change right here. So this is an n inflection point. And then I have a positive slope, positive slope, positive slope, and then a negative slope, which means I change signs again right here. This spot right here, let's do it in pen. This spot right here is an n inflection point. Then I have negative slope, negative slope, negative slope, negative slope, positive slope. I change the type of slope. Therefore, this is an n inflection point also at 4. Second last question, number 6. P increasing, start off with the definition. This is where P prime is greater than 0. What is P prime on a graph of P prime? Well, that is height. So this is translated to height is greater than, that was a bad greater than, is greater than 0. Therefore, this one is height less than 0. P concave up, that's the definition of P double prime is greater than 0. What is P double prime on a graph of P prime? Well, that's slope. So this is slope has to be greater than 0. Therefore, this one is slope has to be less than 0. All right, so where do I have a height that is greater than 0? A height is greater than 0 on this interval between negative infinity to 1 as well as 1 to infinity. So I can come back over here and say this is from negative infinity all the way to negative 1 as well as 1 to infinity. Where am I decreasing? Where is my height less than 0? My height is less than 0 when I'm beneath the x-axis. This is my height less than 0. That was a bad arc. I can do it a little bit better. Still not the best, but I'll take it. And that's between negative 1 and 1. Where am I concave up? I'm concave up when my slope is greater than 0. Slope is greater than 0 everywhere right there. So I just need to say from 0 to infinity. From 0 to infinity. And where am I concave down? I'm concave down whenever I have a slope that is negative. Slopes that are negative are on that left side from negative infinity all the way to 0. I have all of those written up. Let's go ahead and do the graphical analysis. Let's look for critical values. Critical values are where I have a P prime equals 0 or P prime that does not exist. Therefore, I'm looking for a height that is 0 or a height that does not exist. So a height is 0 there, and that's it. So there's my P critical value. So this is a P critical value right here, and my P critical value right here. Now that I know it's a critical value, go a step further. Is it a relative extremum? Is there a sign change? Well, this was a positive height to a negative height to a positive height. Both of those are sign changes. Therefore, it is a P relative extremum. This one is also a P relative extremum. Now that you know it is an extremum, is it a minimum or is it a maximum? You have to define the type of extremum. Well, this one went from a positive to a negative. Therefore, this is a maximum. We'll say P relative maximum. And this one went from a negative height to a positive height. Again, always reading from left to right. So if it starts off with a negative, that is a P relative minimum. Lastly, is there an inflection point anywhere? The change between concave up and concave down is always an inflection point. It was concave down to concave up. That changed right there. So therefore, this point right here is a P inflection point. Moving on to our last question for the homework assignment. Where is f increasing? Definition of f increasing is where f prime is greater than 0. On a graph of f prime, what is f prime? Well, that is height. So translate this to where is height greater than 0? Translate f decreasing to where is height less than 0. Translate f concave up. Okay, use a speed sheet definition. F concave up is where f double prime is greater than 0. What is f double prime on a graph of f prime? That is slope. So where's slope greater than 0? And therefore f concave down is where slope is less than 0. All right, so for height is greater than 0, let's go ahead and highlight those. Height greater than 0. That's everywhere here. Not at 4. At 4, it is equal to 0, and this is strictly greater than 0, so skip over a spot. And then you can say this is still greater than 0, still greater than 0. And then it becomes less than 0 when I'm beneath the x-axis. All right, so let's go ahead and annotate that. We can say the height is greater than 0 everywhere between 0 to 4. We skip over 4, and then it resumes at 4, and it goes all the way to 6. That's where I'm increasing. And then it's decreasing between 6 and 8. Between 6 and 8. All right, where am I concave up? Where do I have a slope that is positive? A slope that is positive, I have a slope that's positive there, 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 and there. All 4 of those intervals need to be listed. So let's go ahead and write that down. We have the slope is positive between 0 to 1. I'm going to do commas because I have a lot of them. Between 2 and 3, 2 and 3. Between 4 and 5, 4 and 5. And lastly, between 7 and 8. Whew, there's a lot of them. Where am I concave down? Concave down means I'm having a negative slope. So negative slope here, negative slope here, negative slope there, all the way down to right here. Oh, weird. I have like sweat on the screen. So there's the last one right there. It really doesn't like water on the iPad. All right. So I'm going to go ahead and list all those intervals as well. This is going to be between, oh, didn't mean to double tap there. It's going to be between 1 to 2, comma, between 3 and 4, comma, between 5 to 7. 5 to 7. Were there 3 intervals? Let me go ahead and highlight them again. There's 1, there's 2, there's 3. Yes, just those 3 intervals. All right, now I just need to analyze the graph and then I'll be done. So first, critical values. I always start with critical values. Critical values are where f prime is equal to 0 or f prime does not exist. F prime is height. So where's the height? 0 or not exist. The height exists everywhere. The height is 0 just at these 2 spots. So I'm going to label those an f critical value right there. And this spot right here is also an f critical value. Those are the only critical values, and then you assess, are those critical values relative extremums? And a relative extremum is where you have an f prime sign change or a height sign change. The height was positive over here and then positive over here. That is not a sign change. This height was positive and this one was negative. This is a sign change, so this is the only one that has an f relative extremum. Now that we know that it's a relative extremum, what type of relative extremum is it? It went from a positive to a negative. It started with a positive, therefore it's a maximum. We can say this is an f relative maximum. Finally, we need to find where we have inflection points. Inflection points are where we change concavities, or where you have a slope sign change or an f double prime sign change. F double prime sign change is a slope sign change. Slope sign change, it was positive, then it was negative. So I'm going to label a bunch of these. This is an f inflection point. This is an f inflection point because it went from a negative slope to a positive slope. This is an inflection point, and there's a lot of them. F inflection point because it was a positive slope to a negative slope. I was a negative slope into a positive slope, therefore this critical value is also an inflection point, an f inflection point. I was a positive into a negative, which means this spot right here is also an inflection point. So we'll say this spot right here is an f inflection point. And then I have a negative slope to a positive slope. Therefore, this point right here is also an f inflection point. Whew, there were a lot of them there. We did get them all, I hope. if I made any mistakes, make sure that you're telling me to get that extra credit. That does conclude AP Calculus AB's Worksheet 3-4 for graphical analysis of F concave up, F concave down, and F inflection point. There's the back side. There's the front side. Thanks for watching.